For centuries, engineers have been cursed with the task of solving the world's toughest physical problems. How can we send humans into outer space? How can we build bridges over great oceans? How can we create a device to perform surgeries with greater accuracy than ever before? How can we cure cancer? How can we get water to go up really small stairs? Though these are all important questions that have troubled the greatest minds of generations of engineers, there is one question above all, one that few have ever dared to face. The question, whose answer could push us off our current path of slow scientific growth and springboard us into a new age of engineering science, is this. What is inside of the Spin Master Etch-A-Sketch? The Etch-A-Sketch was invented by French electrician André Cassagnas, who discovered the idea behind his invention at a factory. By scratching a stylus behind a plastic plate, a few of the metallic particles were drawn to the plate from the other side due to an electrostatic attraction. Cassagnas recreated this phenomenon through his L'écran magique, or magic screen. After being sold to the Ohio Art Company, the revised Etch-A-Sketch was mass-produced and became one of the most popular and well-known toys of recent era. After enthusiastically engraving all that information and other riveting facts into our mind, our group began our scientific breakthrough by going down to the LCIZ in Worth Tower to begin the disassembly of our Etch-A-Sketch. We had been researching the different elements of our item for a while, and in discovering what the Etch-A-Sketch actually used to form pictures, we were a little worried about opening it up. The actual toy is a plastic-encased stylus mechanism, operated by the two knobs on the front exterior of the toy. In order to get inside of the Etch-A-Sketch, we first separated the plastic encasing the machine, attempting to just break it off at the seam. We managed to split it pretty well, but then realized that we also had to remove the knobs. This proved somewhat difficult, and in doing so, we damaged the internal mechanism. For some ridiculous reason, the Etch-A-Sketch was designed to make it difficult for you to expose the interior. In the process of taking off the knobs, we discovered that a fine powder was leaking from the cracks we had formed. Unsure of what this mystery powder was, our combined intellects realized that gloves may potentially be a good idea. Once we finally got the knobs off, we removed the plastic case to see the different segments of the inside. There was a plastic screen adhered to the surface of a black plastic frame on which the design was viewed, and below it was the glass plane totally covered in a fine metallic powder. This is aluminum powder, and it sticks to literally everything, as in there's still probably aluminum powder stains all over the LCIZ. This powder coats almost everything on the internal section of the Etch-A-Sketch, including the design mechanism, the insides of the glass, and the bottom of the board of the toy. There were also fine plastic balls, which are supposedly used to prevent the powder from clumping up. We found the internal mechanism broken by our early attempt to remove the frame, but we were still able to understand how it functioned. The two knobs are attached to wires, which have plastic rods adhered to them on parallel sides. The right knob controlled the wire attached to the long rod going across the mechanism, moving a central stylus up and down, while the left knob controlled the wire attached to the shorter vertical one, moving the stylus left and right. While we had initially thought that the stylus was scratching a design onto the glass, it turns out that the stylus scratches the powder off of the glass, exposing the dark interior of the Etch-A-Sketch, thus presenting any given design. The stylus has holes on different sides that slide onto the plastic rods, and once in place, moves freely around against the window at the twist of a knob. Now we simply collected the powdered contents, likely coating our respiratory systems completely in aluminum in the process. After we removed every segment of the Etch-A-Sketch, we had completely broken down the toy, and we were ready to build it back up to complete functionality. This took careful reassembly of the stylus mechanism, proper alignment of the wires, and gentle placement of the glass and plastic panes. We gently reapplied the plastic frames, readjusted the knobs, and boom! Just like that, we returned to our fully functional Etch-A-Sketch, good as new. As of the recording of this video, none of our group members have suffered any type of side effects from the surplus of aluminum powder we likely inhaled, so our only hope is that we survive to see the grade of our project. However, we are glad to say that at the conclusion of our project, we are proud of the significant scientific breakthrough we have achieved, and we are excited to see just how the application of our discovery will change the course of scientific research for a better future.